Good evening, everyone. In our last videos, we have seen very clearly about what is mean by tree data structure, how we can implement this tree data structure. Next and after that, we have seen what is mean by binary tree, what is mean by binary tree data structure, how we can able to insert the nodes into this binary tree, and what are the various operations that we can able to perform on binary tree also we have seen very clearly in our last videos. Now in today's session I am going to talk about binary search tree data structure. Even we discussed about binary search tree data structure, so where the insertion of elements is based on some sorting mechanism, like the data is going to be stored. So in some format, like the data which we are going to store, I mean, the left hand side, that is left subtree values should be always less than root node, and right subtree values always should be greater than root node. With that principle, we have to insert the data, and even with that principle, we are going to retrieve the elements from tree day binary search tree. That part also we discussed very clearly in our last videos. Now in this binary search tree, we have some problems are there. What is that problem is, for example, so consider I want to insert some elements like 10, next and after that 20, next and after that 30, next and after that 40, next and after that 50. Like this I am trying to insert the elements. So first we will insert 10, then right subtree will become 20, then right subtree will become 30. Next node where we have to insert, like this. Next node where we have to insert 50. So since you can see the height of the tree, 1 2 3 4 5, 5 is nothing but height of the tree, right? Okay, so height is nothing but a 5. Sir, it is very difficult to work with various operations. Like if I want to search, you need to go up to this level. Okay, for any operation, so it will become very difficult. That's why, sir, height balanced trees are required. Okay, what is that? Height balanced trees. Height balanced trees are required. For this height balanced trees, we have so many trees are there. Like we have AVL trees are there. Next and after that, okay, red black trees are there. Okay, red black trees are there. Next and after that, B trees are there. Next and after that, B plus trees are there. Like we have so many trees are there. But in our session in today, I'm going to talk about AVL trees. AVL trees. Sir, what is mean by this AVL? Very simple. AVL tree. AVL trees are self-balancing trees. Self-balancing trees. These are nothing but what, sir? Self-balancing trees. So here, for every node, we are going to take balance factor, BF. What is that balance factor? We will calculate. Okay. So balance factor of an AVL tree is always 0, sorry, -1 or 0 or +1. So among these three values we have to take. Sir, what is mean by this balance factor? How we are going to calculate this balance factor? BF is equal to, very simple, height of left subtree, height of left subtree minus height of right subtree. Okay, if you calculate height of left subtree and height of left right subtree, that value is nothing but balance factor. And this balance factor, determinant of height of left subtree minus height of right subtree, should be always less than 2. That means your balance factor is equal to 0 or your balance factor is equal to -1 or your balance factor of any node is +1 means, so then it is balanced tree. It is a balanced tree. That is, I can say AVL tree. So in the red black trees, that balance will be based on some colors. As of now, it is not required. So I think you people got a clarity about these balanced trees, sir. Now, sir, I want to take two examples for you people. Okay, the first example is nothing but unbalanced tree I want to draw. Sir, what is this unbalanced tree? Let me take one simple example. Sir, I have node 5 is there. Node 5 is there. For this left subtree is not there. Right subtree is nothing but 6. For this right subtree is nothing but 8. For this right subtree is nothing but 10. For this right subtree is nothing but 11. Like this we have. Sir, I can say this tree is nothing but unbalanced tree. Sir, how you can able to say it is unbalanced? If you observe here, what is the height of this particular node? Balance factor of this node is 0, because what is the left subtree height? We don't have any node, so 0. What is the right subtree height? 0. 0 minus 0 is 0. In this node, what is the left subtree? 0. What is the right subtree? So 0 minus so right subtree height is nothing but 1. So your result will become -1. Sir, up to this okay. What about this one? Left subtree height is 0 minus what is the right subtree height? It is nothing but 2. So your result will become -2. Is it balanced? No. So for this left subtree height is nothing but 0, right subtree 1, 2, 3 nodes are there. Okay. So it will become -3. And for this 0 minus 4, which is nothing but -4. So this one is unbalanced tree what we have. This one is nothing but unbalanced tree what we have. Sir, if you take a balanced tree, how it will be? Very simple. I am going to take the same example, like 8 I am considering as a root node. Okay. Next, its left subtree is nothing but 5. So its right subtree is nothing but 10. For 10, right subtree is nothing but 11. So for 5, left subtree is nothing but 3. Right subtree will become 6. Like this I have. So this one is nothing but balanced tree, sir. This one is nothing but what? Balanced tree. Sir, can you please show me what is the height of this node? Balance factor for this node, it is 0, because so left tree is nothing but 0 height minus right tree is nothing but 0 height. So balance factor is 0. But what about this node 10? Sir, 0 is nothing but left subtree height minus 1 is nothing but right subtree height. The total height is nothing but -1. What about this node 6? 0, because left subtree, right subtree 0, 0. And this one is also 0. What is the height of left subtree for this node 5? 1. What is the right subtree height? 1. So balance factor will become 0, 0, 1 minus 1. What about this one? So 2 is nothing but left subtree height. 2 is nothing but right subtree height. So 2 minus 2 will become 0 is the balance factor. Sir, if you see clearly, the balance factor 0, 0, 0, 0, -1, 0. For every node, the balance factor is in between. Okay. So it is in between these things. So we can say this tree is nothing but a balanced tree. So in short form, it can be AVL tree, or it can be B trees, or B plus trees, or red black, anything. But so in this example, I am calculating with the help of a balance factor, right? That's why it is nothing but balanced tree. And please make sure it is BST. It is also BST. So every binary search tree is not AVL tree, but every AVL tree is a binary search tree. Got the difference? Okay. So if you take any balanced tree, first it has to satisfy our balance, I mean a binary search tree properties. Then only we can able to construct. Okay. Of course, I will take the examples for these balance factors, and I will show you how it is going to work. Sir, can you please confirm everyone? Is the introduction to these AVL trees, is it clear for you people? Yes, Vishal, correct. AVL full form is nothing but see, there are three persons are there who introduced these particular trees. Okay, so I think those names are nothing but AVL tree. Beyond that, nothing. Okay, so AVL tree full form. Okay, Adelson, Welsky, and Landis. Okay, yeah. So these people are nothing but inventors who introduced this particular special balancing binary search trees is nothing but those three people. Is there photos of those people? No, I think so. No, we don't have. Okay, but is my definition is correct? Self-balancing binary search trees. So the balance factor should be always -1, 0, +1. Like this we have. Okay. First of all, it should be a binary search tree. Then it has to follow these properties. Can you please confirm, guys, everyone clear up to this? Is the intro for these AVL trees are clear for you people? Please confirm. Right. So the next one, what we have here is, of course, I want to take again diagram only, a new diagram I'm taking. Sir, here I want to insert some nodes like I have 10, 20, 30. Three nodes are there. Three nodes are there. Sir, how many number of nodes are there? Number of nodes will become three. With this, how many possible BSTs we can convert? Number of BSTs is nothing but you can take n factorial, 3 factorial, 6 binary search trees we can frame with the help of these things, sir. With the help of these nodes, we can frame how many binary search trees? We can frame 6 binary search trees. Of course, I'm taking the combinations. Okay. Let me construct one by one. Let me construct one by one. Sir, first I'm converting, I'm taking AVL trees. Okay, I'm taking AVL trees. Now, sir, what is the first combination? Consider I want to insert 30, I want to insert 30, and then I want to insert 20, and then I want to insert 10. These three nodes I want to insert. This is the first tree what I'm constructing. Sir, first, if you insert 30, 30 will become root node. 30 will become root node. Sir, what about its left child? 20 will become its left child. So again, if you insert 10, it will become again its left child. Like this we have. Immediately, you have to calculate balance factor. Its balance factor is 0. 20 node balance factor is left height is 1, right height is 0. So it will become +1. So left height is 2, right height is 0. So it will become +2. So is it balanced tree? No, it is not a balanced tree. Sir, how you can able to convert this into balanced tree? Very simple, sir. Here we have to use one principle called rotation, LL rotation. Of course, I will explain again, don't worry. But just assume we have LL rotation is there. That means where we are getting unbalancing. Okay, it's a left child, it's a left child. By inserting 10, we got this problem, right? So hence it is nothing but LL, left to left. So this is called as LL rotation. In this case, you have to maintain 20 as the root node. Okay, we have to rotate this. We have to rotate this. This is called as, I think, right rotation. Like this, we have to rotate, right rotation. Okay, sir, what we are doing here? 20 we are rotating. 20 will become root node, and 10 will become left subtree of this, and 30 will become right subtree of this. Now, is it a binary tree? First of all, is it a binary search tree? Yes. What about the balance factor? Its balance factor is 0 because of 0 minus 0. It is also 0. Sir, 1 minus 1, it is also 0. So is it a AVL tree or not? Yes. This is nothing but the first combination what we have for this AVL tree. Sir, please confirm, is this first combination? Is it clear for you people? How we have rotated? Please confirm, clear? Right. So now I'm taking the next combination. So 30 I'm keeping as it is. So in the place of 20, I'm taking 10 and then I'm taking 20. Like this I'm doing. Sir, how I am going to take here? 30 is nothing but the first inserted node what we have. Okay. Next, the left child will become 10 here. The left child will become 10 here. And right subtree will become 20 here. Okay, right subtree will become 20 here. Like this we have. Okay, so what about the balance factor? This node balance factor is 0 and left is 0. 0 minus 1 which will become minus 1. So this one, what about this one? Sir, it is nothing but 1 2. Right subtree is 0, so 2 minus 0 it will become plus 2. Like this we have. So is it a balanced tree? No. Is it a balanced tree? No. Then we have to make this tree as a balanced. What kind of rotation it is? By inserting 20 we got this problem. It is right child to this parent, and for grandparent it is left child. So here we are using LL case. This one is LL case where we are doing which rotation? Right rotation. Okay, this is called as LR case. LR case. In this case we have to do two rotations. Okay, we have to do two rotations, sir. We have to do two rotations. What is the first rotation here we have to do? Sir, first we have to do left rotation. Okay, first we have to do left rotation. Sir, if you do left rotation, what will happen? This is right rotation. So this one will become left rotation. This one will become left rotation. This one is right rotation. We are doing left rotation. If you do this left rotation, what will happen? So here we are going to get 30 and 20 will become its left child and 10 will become its right child. So again, you need to check for balance. Sir, its node balance is 0. This one balance is plus 1. This one balance is nothing but a plus 2. Again, it is not balanced tree. Sir, now what we have to do? You need to do one more rotation. What is that rotation? Right rotation. Right rotation. Sir, what we have applied in this case? So this is the same tree, right? Right rotation we have to do. So 20 will become root node. 20 will become root node. So 10 will become left subtree for this and 30 will become right subtree for this. Like this we have to take. Sir, what about the balance factor? Its balance factor is nothing but a 0. So 0, 1 minus 1, it is also 0. So hence there is no problem at all. This is nothing but a second case what we have. Sir, I think you people got a clear clarity about these two cases. Can you please confirm any doubt in these two? I request everyone to please respond. One second. Yeah, so clear right up to this? Any doubts? Right. So let's go with the next one. The next one, what we have here is, uh, yeah. So the next one, what we have here is, sir, assume the next combination, what I am taking. So 10 and next value is a 20. So next value is nothing but 30. Like this we have. Okay. So 10, 20, 30. This is nothing but what we have here. So now here I'm going to take 10 is nothing but my root node, right? First we have to take 10 as the root node. So next 20, 20 will become right child, right? It is going to be inserted in right child. So next term 30 will become right child to this. 30 will become right child to this. Sir, now try to calculate balance factor. Sir, its balance factor is nothing but 0. And left subtree is 1, right subtree is nothing but, sorry, left subtree is 0, right subtree is nothing but 1. So 0 minus 1 will become minus 1 is the balance factor. So here 0, 0 minus 2 will become minus 2 is the balance factor. Like this we have. Sir, now coming to this. So this one is nothing but what rotation? It is a right subtree. For this is also right subtree. So this case is called as RR case. In this case, we have to do left rotation. This one, how we have done here, the same thing. If it is left rotation, 20 will become root node. Okay, 20 will become root node. Sir, its left child will become 10 and its right child will become 30. So what about the balance factor? It is 0, it is 0 and it is 0. Like this we have. This is nothing but what we have here. This is nothing but what we have here. Sir, this is one tree. Now, sir, next, the next combination. So 10 I am keeping as it is. Here I will take 30 and here I am going to take 20. Like this I am taking. So how it will be? First I am going to insert 10. So for this, right subtree is nothing but we have to take 30. And for this left subtree is nothing but 20. Like this we have. So what about the balance factor? Its balance factor is 0. 1 minus 0 will become plus 1. And here 0 minus 2 will become minus 2. Like this we have. So here in this case, it is right subtree. Okay, 1 second. So it is nothing but right subtree. This is nothing but left. Like this we have. Okay. Sir, first we have to do which rotation? This is called as RL case. In this RL case, first we have to do right rotation. Okay. First we have to do right rotation. Sir, what is mean by right rotation? Okay. What is mean by right rotation? Like this we have to shift. Okay. So if you do a right rotation, okay, if you do right rotation, then the nodes will become first 10 will come here. Okay. Next and after that 20 will come here. So next and after that 30 will come here. Okay. 1 second. So what about the balance factors? Its balance factor is 0. It is minus 1 and it is minus 2. Sir, again, it is not balanced. In such cases, what we have to do? The next step is nothing but we have to do left rotation, like what we have done here. Okay. So in this case, if you do left rotation like this, sir, what will happen? It is a right rotation. I think in this direction we have to take. Correct? Huh? Yes. So now here what will happen? Like this, if you rotate, then your 20 will become a root node. Your 20 will become a root node. Left subtree will become 10. Right subtree will become 30. So what about the balance factors? So your balance factor will become 0. So 0 and then 0. This is nothing but what are the different combinations what we have for this. So I think you people got very clear clarity about this. Can you please confirm any doubts, friends, up to this? I request everyone to please confirm any doubts up to this. Right. So still we have two more combinations are there. What is that combination? 30 at beginning completed, 30 at beginning completed, 10 at beginning completed. Now we have to take, so 20 at beginning. So I'm taking, so 20 comma, so 20 comma, 10 comma, 30, or so 20 comma, 30 comma, 10. In both the cases, we will get a single tree. That is nothing but a 10 is not, sorry, 20 is nothing but a root node in both cases. If you insert a 10, it will comes under left subtree. After that, 30 means right subtree. So here also, if you insert 30, first it will insert in right subtree. Then if you insert a 10, it will be inserted into left subtree. By default, this is already in height balanced tree. So like this, if you have to do these rotations. In this, mainly we discussed about how many types of rotations, sir. We have seen LL rotation. Okay, LL case. So next LR case. Okay, LR case. So next one RR case. So next one is nothing but RL case. These are nothing but different cases what we have in our AVL trees. I hope you people got. Okay. So you people got very clear clarity about this one. So in AVL trees, what are the different cases that we are going to get? The first one is nothing but LL case, then LR case will be there. LL case and then LR case. Next and after that RR case and then RL case will be there. So how you can able to get a solution for LL case? For LL case, first we have to do a right rotation. Okay, right rotation. For LR case, what we have to do? First, we need to take left rotation and then we have to take right rotation. Okay. So for RR case, what we have to do? You need to do left rotation. So for RL case, what we have to do? We need to do first right rotation and then left rotation. These are nothing but the rotations what we have to do. But we have only two rotations. One is nothing but what? Left rotation, and the second one is nothing but what? Right rotation. These are the two rotations what we have. So based on that, the total tree is going to be formed. So please confirm everyone, is the concept is clear? Yeah, Vishal, I will explain, don't worry. Clear up to this? Right. Now, sir, I need to go with some other diagram. Okay, here AVL tree is completely diagrams, sir. Okay. So the first diagram, what I'm going to take here is LL case, LL case, AVL tree example, AVL tree example. Okay, I'm not taking any notes, just I want to take the representations and I want to show you how it will be. Okay, for example, consider here I have node is there called A. Okay, node is there called A. For this A node, B will become left subtree. B will become left subtree and C will become right subtree. Listen carefully. B will become left subtree, C will become left subtree for this. Sir, this A already left subtree is there. AR will become right subtree, right child. For B, so BR will become right subtree. For C, we have CL is nothing but left subtree node and CR will become right subtree node. Sir, in this which rotation we have to apply? So this one will become, okay, this one will become left subtree. This one is also left subtree. It is unbalanced. So we have to do which rotation? So LL means I told very clearly. So LL means right rotation we have to do. Okay, right rotation. We are going to do right rotation. Once if you do right rotation, sir, root node will become B. That we know very well. Root node will become B. For this, A will become left subtree. That also we know very clearly. And C will become right subtree. Right, perfect. What about these remaining nodes? Very simple. For CL is there, right? Oh, one second, one second. So which one will become root here? Which one will become root here? B, right? Then your left subtree will become not A. The left subtree will become C because it is lesser than B. So A will become right subtree. Now, so B will become root, A will become right subtree, C will become left subtree. Sir, now for C, already left node is there. It will be available as it is. Right node will be available as it is. But for A, sir, for A, right node will be as it is available. Since we have done this rotation, BR means what? Which is greater than B, right? Which is greater than B. Once if B became root, BR will be greater than B means it should comes under right subtree. But in the original tree, BR is there in left subtree. That means what? It is lesser than A. So we have a conclusion that so BR should comes under right subtree and it is left to A. So here BR will come. Very simple scenario. So this is nothing but what is the LL case. So with AVL tree example. Okay. So Vishal, I think you got clarity now. Can you please confirm everyone? Is it clear this case? Because based on this only, so tomorrow example program will be there. There you should not ask queries. Clear up to this? Right. So the next one, what we have here is, sir, LR case. Okay, LR case, AVL tree example I want to take. LR case, AVL tree example. Become left child. B will become left child. Okay, and then C will become left child. C will become left child. Sir, for B, BL is nothing but left child. And for C, CL is nothing but left child. So CR will become right child. And for this A, AR will become right child. Like this we have. Sir, now it is which rotation? It is nothing but left to this and right to this, LR. In this case, we are going to get two diagrams. Sir, first we have to do which rotation? Sir, in the LR case, first we have to do left rotation. Left rotation we have to do. Sir, once if you do left rotation, okay, left rotation, sir, what will happen? So your A will become as it is. Your A will become as it is available. Okay. So this is the left rotation. C will become child for this A, left subtree, and sir, B will become right subtree here. Okay, and for B already BL is there, and for A already AR is there. Sir, what about C children? For C, CR will be available as it is. Sir, what about CL? It is less than C. That means here. Okay. So it is less than C. And sir, it is greater than B, right? Yes. So it will come here. So CL will become here. Okay. Sir, again it is same like this one, right? In this case, again we have to do which rotation? Right rotation. We have to do right rotation. If you do right rotation, sir, your C will become parent node. Your left subtree will become B. Your right subtree will become A. Like this we have. So for B, BL will become left subtree. So CL will become right subtree because already it is there. And for AR is nothing but right subtree. Left subtree will become CR. Already I explained. So this is nothing but the new tree once if you do this LR case. Sir, clear about these two cases? Please confirm everyone. Sir, I don't get left rotation in LR case. See, in the left rotation, observe carefully, A, B, C, if you have like this, L, R, okay. So B is nothing but left subtree to A and R is nothing but right subtree to B. In this case, this particular tree is not a balanced tree. That means when you are adding C, if it is imbalance, then only we have to do this. If it is balanced, don't touch this. Okay. So when by adding C, if you are getting unbalanced, then what we have to do? Sir, LR case, this one. In this case, first we have to do left rotation. Left rotation means what? With respect to newly added element, you have to do left rotation. That means C will come here and B will comes under left subtree. So C will come here, B will become left subtree. Just sir, keeping the point and rotating, that's all. Okay, C will move here and B will come like this. This is called as left rotation. So this is the style. So not whole tree. No, no, no. We are not rotating the total tree, sir. Wherever we are getting the problem, when you are adding the node, balance factor, you are going to get issue, right? In such cases, we have to do this. Got it? Yes. Sir, I request everyone to please confirm. Clear up to this? Right. Next. Sir, one more diagram I am taking. One more diagram. So here we need to talk about which one? Sir, RR case in AVL tree. RR case in AVL tree. Example. So what is this one? What is this one? Sir, here consider A is nothing but root node what we have. Yes, based on balance factor. See, Anil sir, whenever you are adding a new node, you are going to have an issue with the balance factor. So after adding the value, you have to check balance factor. If your balance factor is in between 0, -1, 1 means you can keep as it is. If it is not in between those, what we have to do? You need to do rotations. Got it? Right. So here A is nothing but the node what we have. AL is nothing but its left child. And here we have B is there. For B, C will become child node. Sir, then BL will become left subtree, left node. For C, CL is there and CR is there. So here we are going to get the problem by adding this C. Sir, it comes under which one? Right subtree, right. So if it is right subtree, right, which rotation we have to do? Left rotation. So we need to go with left rotation. We have to apply left rotation. Once if you apply left rotation, what will happen? Sir, left rotation means what? Sir, we are going to do left rotation like this we have to do. That means what? Your B will become root node. Your B will become root node. Okay. Then your A will become left subtree and your C will become right subtree. Now observe carefully. So for A, AL will be as it is available, and this BL is there, right? That will comes here. And for C, CL will be available as it is. CR will be available as it is. Very simple, sir. Now I need to go with the next case. What is the next case here? So RL case, AVL tree exam. How you can able to take this RL case? Sir, very simple. Consider here A is nothing but root node. For this AL will become left subtree. For this B is nothing but right subtree. And for B, so we have, okay, for B, we have C is nothing but left child. For this, we have CL and then CR. For B, we have BR is there. Like this we have. So what we have to do first here, this will become right child, left child. So if it is RL rotation, first right rotation we have to do. Sir, first we have to do a right rotation. Right rotation means what? Sir, something like right rotation in the sense like this, right? Like this. That means A is already available, which will become child for A, C. Okay, because here it is in order. That's why B came first. But here it is in different order. So C will come here. C will come here. Okay. ACB only. ACB only. Why you have a doubt? Where we have taken ABC? ABC, right rotation we are doing. No, ACB only. No, check it once. See here. So this is the node which we have to do right rotation. If you do right rotation, what will happen? A will become your root node. A will become your root node. So its left subtree will become, sorry, its right subtree will become C, and its right subtree will become B. For B, already BR is there. Already BR is there. Next here, here C left will come. So here A left already available. Since we moved this C here, sir, B will come down. That means here we are going to get what? CR. Because, sir, it is greater than C. Okay, it is greater than C. That means greater than C, but less than B, right? So it comes here. Sir, now is it balanced? No. Then after applying right rotation, which rotation we have to apply? Left rotation. Now we need to do left rotation. So left rotation with respect to this means like this we have to rotate. Sir, which will become root node now? C will become root node. For this, left subtree will become 8, A. Right subtree will become B. So for B, already BR is there. It will be available as it is. For A, AL is available. Sir, what about this CL? It is less than C. It is less than C. Definitely it should comes under left side, but it is greater than A, then only it came here, right? That's why CL position is nothing but this one. Sir, CR, it is less than B. Okay, and it is greater than C, that's why it will come here. So definitely it is a balanced tree, sir. Again, if it is not balanced, we have to apply these rotations like this. Okay, I think, sir, you people got a clarity about these rotations, how we can able to do. Can you please confirm any doubts up to this? Everyone, please confirm any doubts up to this. Yes, I request everyone to please respond. Use case means nothing. In the tree data structure, to maintain accuracy, we are going to use these kind of things. Okay. When we are adding the elements, keep on adding means complexity is going to increase for every time. So that's why just to reduce that, we are using these things. Okay. Right. So next, I want to take one more example, creation. Anyway, last example. So creation of AVL trees, creation of AVL trees. So tomorrow we are going to implement this one. But as of now, I'm trying to insert. So 40 and then 20 and then 10 and then 25 and then 30 and then 22 and then 50. Like this, I want to insert. Wherever we are getting the unbalancing, okay, balance is not there means unbalancing means, so we have to do proper rotations. Okay, now we will see by inserting the elements one by one where we are getting problem, how we can able to solve that problem, we will see. Okay, now sir, let us see one by one. Okay, sir, first I'm going to insert the first node, which is nothing but 40. Okay, sir, what is the balance factor for this? Since we have only one node is there, its balance factor is nothing but 0. Now I want to add 20. Okay, I want to add 20. For 40, this 20 will become left subtree, right? 20 will become left subtree. Okay, now check the balance. Sir, it is 0 and height is nothing but 1 minus 0, which will become plus 1. So no issues up to this. 20 also inserted. Now add 10. It will become left subtree to 20. Okay, it will become left subtree to 20. That means, so 40 is there. Okay, so next 20 is already there. Okay, these two are already balanced. By adding 10, we got some issue. Sir, why? If you check balance factor, it is 0, it is nothing but a plus 1, and this will become plus 2, right? 2 minus 0. Sir, is it in balance? No. Then which technique we have to apply? LL. Sir, LL means which rotation? Right rotation. Sir, we have to do left rotation means in this direction. The right rotation means in this direction. So which one will become root node here? 20 will become root node. Okay, 20 will become root node. So for this 20, okay, this 10 will become left subtree, and then so 40 will become right subtree. Try to calculate balance factor now. Sir, it is 0, it is 0, it is also 0. So no issues with this, no issues with this. Now what I'm going to do, I will insert a 25. It is greater than 20, less than 40. So 25 will be inserted here, 25 will be inserted here. Okay, let us rewrite this one again. So 20 is there here. Okay, so next 10 is nothing but left subtree. Okay, 40 is nothing but right subtree. Up to this balance is there, and we have to add 25, which will become left subtree like this. Okay, so now what about balance factor? So this will become 0, this will become plus 1, and this will become 0. So this is 1 minus 2 minus 1. Sir, it is also balanced, right? Hence no need to disturb. Now what is the next one? We have to insert 30. We have to insert 30. Sir, let us see here how it will be. Sir, 20 is nothing but root node. Okay, for this 10 is nothing but left subtree, already it is there. 40 is nothing but right subtree, already it is there. Sir, 25 is there. Up to this there is no imbalance, everything is correct. By adding 30 greater than 20 less than 40 greater than 25, here we are going to add. Sir, by adding this 30, definitely we know this height is nothing but 0, this height is -1. Sir, what about this height? Left subtree height is nothing but 2. So here we are going to get 2 minus 0 means 2. And here it is 0. Sir, 1 minus 2, 1 minus 3, it will become -2. Like this we have. Sir, it is a problematic, right? What kind of rotation is required? This newly added tree is nothing but right subtree for this child, and its grandparent is nothing but 40 for this left child. LR. If it is LR, first we have to do left rotation. What is the left rotation here? Sir, left rotation means like this we have to do. Okay, like this we have to do. Sir, if you do left rotation, what will happen? So if you do left rotation, sir, 20 is nothing but, so 20 is nothing but root node. So 10 is left subtree, there is no disturbance up to this. Now here right sub, among these three we are taking, so 30 will become root node, right? 30 will become root node. Okay, then sir, 25 is nothing but a left subtree, and then 40 is nothing but right subtree. Like this we are getting. Okay, sir, is my voice is clear? Please confirm. Sorry, is my voice is clear? Right, right. So now try to calculate balance factor. 0, 0, 0, sir, 0, 1 minus 2. Okay, 1 minus 2. Sir, what about result? -1. Sir, it is balanced, right? Yes, up to this there is no problem, sir, everything is balanced. Can you please confirm up to this stage, is it clear for you people? Please confirm, everyone, up to this stage, is it clear? Right. Now, sir, next, so which node we have to insert? 22. Okay, 22. So 20 is nothing but main tree. For this 10 is nothing but left subtree, and right subtree is 30. For right subtree, 40 is the left sub right subtree. So 25 is the left subtree. For 25, we have to add 22. So your 22 will become left subtree for this. So what about balance factor? It is 0, it is 1, it is 0. So 2 minus 1, it is nothing but a plus 1. It is 0. So 1 minus 3, it is nothing but a -2. Is it balanced? No. We have to do this. Sir, by adding 22, we are getting problem. It is left child to left. LL means which rotation we have to do? Right rotation. LL means which rotation we have to do? Right rotation. Like this we have to do. Sir, 1 second, please wait. Sir, we have done a small mistake here. Okay, we have done a small mistake here. Okay, what is that mistake here is I'm writing in green color. See here. This is LR problem we got, right? LR means what? Left rotation we have to do, left rotation we have to do, and then right rotation we have to do. Sir, left rotation means what? So 40 will be as it is available, 30 will become left subtree, 25 will become left subtree. Again we are going to get the problem. In this case we have to do a right rotation. Anyway, after doing this right rotation we will get this tree only. But in between, this particular scenario is there. Just I forgot, because see, when you are having only one side, either left or right, you need to do only one rotation. But if it is in this shape, you have to do two rotations. Okay, sorry for that. Now, sir, it is LL. LL means what? How many rotations we have to do? Only one rotation. Sir, since it is left, which rotation we have to do? Right rotation. Okay, we have to do which rotation? Right rotation. Right rotation means what? In this style we have to. Sir, then what about your nodes? Sir, main node is nothing but a 20. Its left subtree will become 10. So its a right subtree is nothing but, so it's a right subtree. What we are going to get here is 25. 25. Okay, because we are doing this rotation. 25 will become root node. 30 should come here. Okay. Sir, it is something like which style? Have you observed here? Remember LL. Yeah, in this case, right? If you see, so here 30, 25, 22. So 30, 25, 22 is there, and unfortunately this 40 is there. In this case, which should become root node? B. 25 should become root node. 25 came as a root node. So then what we have to do for 25? So who is left child? C. C is what here? 22, right? It will become left child. So who will become right child? A. A is nothing but 30 here. So A will comes under right child. Okay. And what about this 40 AR? It should come right child of A. So that is for 30, we have to get 40. So like this we are doing here. Okay. Sir, again we need to check. Okay. Again we need to check the balance factor for this. So what is the balance factor for 40? 0. For this minus 1. For this 0. For this minus 1. For this minus 2. Sir, by rotating these, we are getting a problem. What is the newly inserted node? 22. It is left child to this node, right child. So again, we have to apply LR principle. If you take LR principle, sir, what we are doing here? Left rotation and right rotation. So first left rotation and right rotation. Okay. Now I want to apply left rotation here. Once if you apply left rotation, okay, once if you apply left rotation, sir, what will happen? Here, right, left rotation means like this. So who will become parent? 25 will become parent. Okay. For this 20 will become left subtree. For 20, 10 will become left subtree. This 22 is less than 25. That means immediately it will move to left subtree. It is greater than 20. So 22 will come here. For 25, 30 will become right subtree. For 30, 40 will become right subtree. Like this we are getting. So for this balance factors 0, this one is minus 1. So 0, 0, 0. Sir, 2 minus 2, 0. Sir, perfectly it is height balanced. Okay. Sir, now we have to insert a 50. Can you please confirm, is this concept is clear for everyone? Is this concept is clear for everyone? Right. Now we have to add, sir, how to decide to rotate on the node? Very simple. We are not going to decide. We will write the program. Whenever you are adding a new node, it will check balance factor of this node. If the balance factor is same, I mean, it is a proper balance factor, it will check its parent balance factor. And it will check its parent balance factor. Like every node balance factor, it will check. Okay. If anywhere balance is not getting, it will observe that node and it will do the rotation. We have to write code for that. See, it is the same like binary search tree insertion. We are going to search for the proper location and we will insert it. Then we will write some two functions for left rotation, right rotation. So if a balance factor is less than and the element is less than means we have to apply one technique, LL or LR, that we will explain in the next class. Okay, but physically try to understand. What is the next node? 50, where it has to be inserted here. Directly I'm writing here. What about the balance factor? Definitely it is not going to match because it is 0. So it is -1. So it will become -2, right? So here itself imbalancing is there. Sir, newly inserted node is right child to this right. Which rotation we have to apply? Left rotation. That means like this we have to rotate. Sir, your tree will become 25. 40 will become root node. 30 will become left subtree. Sir, 50 will become right subtree. And 20 will become left subtree, 10 will become right subtree, 22 will become right subtree. Like this we have. Try to calculate balance factor. 0, 0, 0. So 0, 0, 0. 2 minus 2, 0. Perfectly balance factor got satisfied. This is the way how to insert the elements into binary, I mean AVL tree. I hope, sir, you people got very clear clarity about this one. Can you please confirm? Is it clear up to this? Okay, please confirm everyone clear up to this. Right. But sir, we will check really is this node is a proper node or not. Okay, I need to check. I need to check really is that nodes are properly working or not. How you can able to do that? Sir, AVL tree construction online. Any website is there for this? Yeah. Some tool is there here. We will check. What is the first node that we are trying to insert? 40, 20, 10. The first node which I am giving is nothing but 40. 40, try to insert. Sir, 40 came right. So next node which we have to insert here is nothing but sir 20. 20. I want to insert 20. Okay. Have you observed? We got here. Okay. Still is the Zoom is available. Okay. Sir, next, which node we have to insert? Can you please tell me? 10. Please guide me, sir. 10. So if you insert a 10, so it will check and some problem is there. It is going to rotate and 20 will become root. Okay, 10 is left and 40 is right. Correct, right? Sir, now we have to insert 25. We have to insert 25. Okay, try to insert. It will check and left subtree. Rotation problem is coming. Balance factor is not satisfied. Balance factor, sir, you can see. So 10, 20, 40. Yes, everything is correct. Okay. I think balance factor, it is 3. Okay, we will do after this. So 10, 20, 40, 25 completed. Then we will insert 30. Correct, is it? So 20, okay, 20, 10, so 30, 20, 10, 30, so 25, 40. Okay, good. Sir, now which element we have to insert? Next one. So 25 completed. After that 30, 30 also completed. Yeah, 22. 22 and last number is 50. Remember, sir. 22 I am taking, try to insert. Here problem is there, again problem is there, so it is rotating. Sir, what will be your new list? You can able to see, sir, 25. Okay, 25, and then left subtree will become 20. So 10 and 22, yes. So again 30, 40 is there. Okay, now we have to insert the last element, 50. Correct, Swapnil, good. So 50, try to insert, it will be inserted there. So automatically problem is coming. So then it is going to do rotation like this. Sir, now cross check, is it correct? Sir, 25 is the root node, 25 is the root node. So 20 will become left subtree, 10, 22 right subtrees. So 40, 30, 50, like this we are going to get. This is nothing but what we have. So like in the in order, it is printing all the data. Okay, I think, sir, you people got a clear clarity about this. Okay, you people got clear clarity about this. So if you want in detail, just try to remove all these things. Okay, try to remove all these things and check how it is going to work. uh, Last inserted node is what? 50, right? I reduced the time and just you can see how it is going to be deleted. Animation speed I reduced. You can able to see how it is going to delete. Once if it is deleted, so there is unbalance, how it is going to be balanced. Okay, how it is going to be balanced, it is going to check. Okay, so I think better I will share this link also for you people in the notes. So even like this, we have some other websites also there. So you can cross check which tree you need by balanced search tree. Yeah, you can check. I think here it is not there. I think here you can check. If I want to insert a 55, where it will be inserted. So if I want to insert 56, where it will be inserted. So automatically it is doing. I think you can see animation is coming here. Okay, so this is the way how physically, I mean how diagrammatically we can able to see. Deletion is also same, sir. So anyway, we are going to write the code tomorrow for this AVL. Okay, so in that AVL tree program, I am going to explain insert and then delete and searching operation. It is the same like BST. So same like BST, only that height attribute will be there. So get height method will be there. Okay, next and after that rotations, left rotation method will be there, right rotation method will be there. Okay, so like this get balance factor. So like we are going to define some few methods, we will discuss that in the tomorrow session. Maximum tomorrow I will try to finish that AVL tree program. Okay, with that AVL trees are going to be finished. Okay, so tomorrow don't miss the class because big program we are going to get. Okay, right. So thank you friends, see you tomorrow. Thank you. I will upload these notes, don't worry. Good night.